So thank you everyone for joining us on today's webinar. We're going to be having a look at part inspection, and as a single reason why this is enough for you to upgrade to the manufacturing extension. First of all, let's have a look at what we're going to be covering today. We're going to have a quick look at who I am, where am I from, hopefully you can guess by the accent, and then we have a look at why do the extensions exist. Have a look at the machining extension, how this fits in with our core offering versus the machining extension. And then we're going to have a look deep dive into part inspection itself. We have a look at two topics, one of them being how to actually update the toolware on our controller live, and then the other one being about part alignment. How do we machine things like these forgings that I've got here? They're actually 3D prints, but they're representative of a forging. How would we hold those? And then how would we datum them? It's all made possible with Fusion 360 and our part alignment functions. That's what we've got on there today. We're then going to have a quick look at a really good case study. I like it, not because it's one of our normal, very highly produced case studies. It's a real honest example that I hope all you out there can relate to as well. Then we're going to talk about what next steps you need to take to actually make use of the hopefully things you've learned in this webinar and how to take that forward. So a quick introduction to me. My name is Richard Stubley. I'm a senior technical consultant at Autodesk. I came via apprenticeship route. I did a 4-year apprenticeship. I did about 7 or 8 years then in industry, in quality control, metal forming, forging, CNC machining. And then there was a position at Autodesk in metrology. So it was a natural fit for me to go from being quality and CNC to actually doing the metrology and probing on the machines. If you didn't guess by my accent, I am based in the UK. We've got an amazing technology centre in Birmingham. It's one of the 5 technology centres we've got all over the world, and we specialise in advanced manufacturing. If any of you ever get a chance to go to one of our tech centres, jump at it. On a personal note, engineering's a passion for me, not just a job. You can see there, I've just finished building my Cova replica. And that was 3 years in the making. And I used Fusion 360 for quite a lot of the bits on there as well. So enough about me. What are extensions? So extensions are extensions. They allow you to extend the functionality of Fusion 360. So this is rather than having a separate application for every discipline you want to go in, you can extend Fusion 360 to do those higher level of activities that you'd normally need a dedicated package for. I'm sure we've all seen it where certain people in a company have a lower end of a package, then others have a top tier of a package, and they just can't share files between them. They could be a different file base completely, different licensing agreements, and all the pain that flows along with that. Extensions allow you to jump in and out of functionality as and when you need them, or as your colleagues need them. You can all be working on the same data set and actually put that data to and from as we need them. The manufacturing extension is going to add simplification to our programming processes. And then I'm going to talk about the integrated metrology. So think about this. We've got the CAM system that we know as Fusion. I'm sure a lot of you are programming subtractively manufactured parts there today. If you wanted to do metrology, you'd have to go for a separate metrology package. With the extension, we allow you to keep all that existing Fusion knowledge and experience you have and apply that in the metrology world. No need here to export the file, open up another application, go into there, which is going to cost you an order of magnitude more than what the extension does. Forget the fact that the workflow is just so much nicer. So the machining extension. There's lots, the extension is jam-packed full of functionality, but today we're going to be focusing just on the inspection. So please don't think this is all the machining extension is. It's full of loads more than this. I can only cover a small amount in the time we've got here. So we look at in-process inspection. So as the part's being made, how do we automate things like tool wear? How do we prevent scrap from happening on our machines? We'll look at advanced part setup with that conrod that I showed you earlier. How would I go about holding that, fixturing it, datuming it? And then at the end of the day, all we want to make you do is produce better quality parts more efficiently. That's the whole point of CAM. CAM is there to make your machine work more efficiently and produce better parts. CAM on its own just puts pretty pixels on a screen, does nothing else. It's all about driving that machine tool, making sure the parts you make are to specification, and also be able to produce reports on that for your customers or for internal processes. So the machining extensions we see on the right, we've got our core offering on the left there, some real good base level functionality that everyone's going to be using. And that allows you then to tap into the extension when you want it. So the machining extension has all those features we've seen. They've got advanced milling with steep and shallow and 4-axis rotary, automated drilling in multi-axis with hole recognition, just to improve your efficiency. Let's spend less time clicking on the screen and more time making chips on the shop floor. Toolpath editing to make sure that you've got ultimate control over those toolpaths, and then inspection that we're going to be focusing on today. So hopefully everyone out there, please in the chat, are people doing inspection now? What kinds of things are you doing with it? Is it just sat in a drawer collecting dust and you're hoping this is going to be the key to using it? Let me know. I'd love to get some interaction. I'd much rather spend the whole time answering Q&A than get to my presentation. I'm sure Jason wouldn't appreciate it though, who's listening in. But anyway, let's get straight into the demonstrations and see what I've got planned for you today. We're going to have a look at updating the toolware on your controller. Before, this was a very laborious process of having to know a load of commands. And then we're going to show something really special with part alignment. How do you align parts that you could never even dream of quoting before? So let's jump into Fusion. Again, come on, people, let's get some questions in the chat. I'd much rather the engagement from your end. You know, no pressure, but this morning we had some really nice questions. So a bit of a competition going on there between the two geos. This is the part I made about 4 weeks ago. This was made out of solid titanium. I mean, let's have a quick look at how big this part actually is. Is it about 400 mil? Yes, and I am talking millimeters. About 460 millimeters long. I think it was about 3,000 pounds. I know I'm really going for it in the units and conversions today. So 3,000 pounds, I think the order was for this material. We could not scrap this part. It was very important. We had a big bearing face on the inside that had quite a tight tolerance. So what were we using? We were using in-process inspection to actually look at any deflection and any toolware we had. So that's really important. Tools change in two ways. The physical size of them does change. Out the box, a 16 millimeter end mill won't measure 16 millimeters. It might measure 16.00001 millimeter, but still, it's still going to be slightly different. Normally, the more you pay for it, the more accurate it's going to be, but it is going to be different. Even some of the most expensive tools, after they've been reground, their diameters do slightly change. So that's the physical size of it. Again, when it wears, it slightly changes. We've then got the relative size that I'm going to be calling that. And that's the actual deflection we get when we're cutting a feature. So the physical size can change, but then also because the tool can deflect as we cut a feature, we need to try and compensate for this deflection. So what we have now is we have a 2D contour finishing off this bore for us. I'm now going to inspect that and see, has it been measured, has it been machined correctly, and update my toolware based off of that. So I'm going to go probing, probe geometry, select my tool, and we can count the clicks. I'm on number 3 already. So not many, 4. We're going to choose that. We've got a five clicks going on now, and we're going to choose a reference operation. So I've chosen a reference operation there. I've gone through, I've ticked update toolware, and I've chosen a reference operation. That's going to pass through all the information I need to the macros to update this toolware. So you've got to think, all I've had to know there is 6 mouse clicks. I haven't had to know G65P9810 is a protected positioning move. G65P9832 is to turn the probe on. Is it 9814 to do a circle? I can't remember. You know, you'd have to know all of those codes, or, you know, 5 mouse clicks. I know which one I'd rather be doing every day. What this is going to do is send the commands through to the machine on the tool, on any stock to leave that was applied, on any tolerances, and the orientation that we need to update it in. I'm not going to get too much into that now. I will fire into the chat, though, a full-on tutorial about how to use toolware update and probe geometry. So if you do want to watch that, please don't watch it now. Wait till after the webinar and watch that tutorial on the probe geometry. I'll be discussing in a lot more detail all the options. But what we can hopefully see is graphically from inside of Fusion 360, I've just managed to program what is a very complicated probing routine where we're going to probe something, look at the toolware and adjust it within a certain value. So really quite a complex routine, but only requires a few clicks from myself. So I can see some of the chat questions coming in. I'm going to cover these later on as we go, but I really appreciate the interaction. Keep them coming in, and I'll definitely leave some time for that as we go. That was updating that toolware. What I can also do, let's just edit that option. Let's have a look at some of those actions. I've got out of position and out of size. So again, all I'm doing is clicking checkboxes in Fusion, not having to know that, oh, completely, is it W1? No, W1's not. I can't even remember the command for an out of position alarm on the Renishaw macros. But on this machine, all I need to know is if I want the alarm, I tick the box. Now that's definitely worth the extension alone, not having to try and sift through manuals, spending time on working out how do we program this. With the extension, we can program these routines from Fusion and improve the part quality. Most importantly, try and reduce some of that scrap that I'm sure everyone is unfortunately making. You know, when I used to work on the shop floor as quality, we used to look at the scrap and we used to try and work out how to dial that scrap down. If only I knew then about the tools that we had available to us. So this is going to look at part alignment. Now, castings, forgings, 3D prints, near net shapes are extremely difficult to hold and to datum. They're really difficult to hold because you can't grab around the whole of the part because you're going to naturally obscure some of the machining faces. And you also can't hold all the part because you may be going to cover over a datum face. However, you can see how simple this fixture is. 2 dowel pins, 2 clamps. And I'm not just doing this as pixels on a screen. Here is the fixture. I machined 10 of these parts a few weeks back, and this process worked an absolute treat every time for me. So what we're showing you there is using part alignment, you can reduce the costs of fixturing. I've done this before with 3D printed soft jaws. I had to make some one-off parts that I was engraving. I had no way of holding them without scratching them. However, some 3D printed soft jaws with a little bit of actual, I used some rubber on the inside of them so to not scratch the parts. It worked an absolute treat. With part alignment, all you need to do is hold the part and we'll worry about the datuming of it. Of course, we need it relatively in a position that we can probe it, but we then make it accurate from there. So how does this work? This isn't a tutorial. Tutorial will be in the chat if you didn't guess, coming up soon. These are all the inspection points that I've got across my part. I run that inspection on the machine tool. I get the results back and they look a little bit something like this. This is the results as they are on the machine now. We can see that this point here, that's over 1 millimeter out. That point, 1.3 millimeters out. You know, I'm going to get probably a broken tool on the side with too much material and something called non-cleanup on the side without enough material because the part's not in the right location. Part alignment is an advanced algorithm that actually works out how it can shift and rotate that part into its perfect location. So I'm going to tick, let's display these results after the alignment. You can see now the results are looking much better. I can look and see what we've got here. This is only 300 microns out. So rather than millimeters, we're now talking in microns. So I can make a judgment on that and work out, should I still be able to machine this part? And that's something that's really beneficial here. I'm going to be able to tell you using part alignment, if that part is scrap before you even touch it with a machine tool. Have you ever had parts with distortion? We can work out, are the parts so distorted they'll never clean up? Now, if that's not a reason to use the extension, I don't know what is. You know, you're going to save so much time and money by not machining what is inevitably going to be a scrap part at the end of it. So the algorithm then works out, it needs to rotate this way, shift slightly. We then post out dedicated NC code for that orientation for that part, knowing that the part's going to be aligned perfectly every time. And again, that was really quick. If you do want to watch a tutorial on that, you'll see it in the chat now. Let's jump back over and finish off this webinar really quick. Can't believe that's done in 15 minutes. That time has flown by. So the quick case study I want to explain. So this is Conturo prototyping. Precision manufacturing, however, they had a problem with their bandsaw. It cut their billets off square. Now they have a very little wastage on these billets, that they've got the process nailed down. However, when they were off square, they could not get them in spec. You can see there we've got non-cleanup on the side. They used part alignment, they turned part alignment on, used part alignment, and paid for itself on this one job alone. Not only in the wasted material, but also in the fact that the spindle kept turning. The machine wasn't sat idle waiting for new material or for the machine to be fixed. We managed to use part alignment. We got all those billets individually orientated because every one was different. Imagine that. You'd have had to have unclamped your vise, clamped the billet in, got the DTI out, run it up and down the side of the part, and worked out the individual orientation of every one. That would have been a nightmare to have done. Using part alignment does all that for you mathematically via the NC code. We haven't got to start worrying about moving our vise from its perfect location. Let's do it all via the software, much easier to do. So let's jump into some of the questions. We've had a look at who I am, what are the extensions, as far as the functionality in them, focused on that parts inspection, and we've had that really nice case study. So what I want everyone out there to do today, watching this webinar, is please try the free trial of the extension. Have a look on your machine, run some of these processes through and see how you can use it, how you can actually make this produce better quality parts on your machine tool. If you don't want to click the link in the chat, feel free just to scan the QR code on the screen now. Let's head over and do some of the questions. So where do the in-process inspection reports go and how to view them on the machine tool? So depending on your macros, you'll hopefully be able to print out a results file. That does slightly change for what's going on. You can see I'm slightly prepared for this. In the chat now is a link to a tutorial on how to import those results back in. That's how to import the results from the macros and from Inspect Surface, import them back into Fusion and see them graphically on there. It will vary slightly from controller to controller, but hopefully that'll give you a good grounding on how to do that. Right, let's have a quick look at some other questions. I've recently purchased a 1996 Haas VR3. It came with an OMP60 probe. I plan on using the Renishaw tool setter. How will this extension improve my workflow using Fusion? Okay, perfect. So you'll basically be using what we've just shown. You'll be using your probe in process. I want people to use their probes like any other milling tool. You need to be thinking of a probe like an M mill. It's going to add just as much value to your part. Though it's not removing material, it's still adding value. Making sure the parts are correct, getting those quality reports out there for your customers is going to just show how much you care about the fitment of your components. So again, everyone, thanks really much for the questions and the engagement. Not going to say this was better than the one we did this morning, but there were some really nice questions in here today. Look, you know how to contact us on the forums. I personally really like engaging with customers. Hopefully you might have watched some of my other videos beforehand. Make sure you subscribe to our YouTube channel and make sure you actually apply for this free extension trial. Going through the link there will actually get you to a dedicated technical consultant who will have a quick conversation and make sure you get the most out of your trial. The last thing we want is for you to have your trial, 30 days goes by, and you didn't get the full benefit out of it. So make sure you use that link down below and we'll make sure you get the best out of that trial period. With that, I'm running out of time very quickly. So thanks everyone for your time today. I really appreciate it. Enjoy the extension trial and happy inspecting. See you all again next time. Bye.